We have completed gas welding. Now we have to start arc welding. So the major difference between arc and gas is, in gas welding no need of external power, electrical supply is not there required. So but in arc welding electrical power supply has to be there to generate the arc. So in gas welding we generate heat for joining of two metal plates with the help of gases sent from the cylinders. Similarly, in the case of arc welding, to join two plates we use electric current as the heat source, which is sent from electrodes, which helps to melt the joint and helps the formation of a joint. That is arc welding. In arc welding again there are few types. Arc welding power supply is used as heat source joint formation. So if there is no electrical power supply you can't do arc welding. There are different types of arc welding. First one is TIG or tungsten arc welding. TIG means tungsten inert gas welding, or gas tungsten arc welding, or argon arc welding. So different names. Here the electrode is, which non-consumable electrode is used. Non-consumable electrode is used. So it is like simple layout. I will just draw arc welding. Looks like this. This is workpiece and anode and cathode. This is electrode. Here the arc will generate between anode and cathode. When you send the power supply, the distance between anode and cathode is closer, so at some point of time electric spark will generate. Because of that heat energy will develop. Due to heat, the molten metal, the plates will melt and form joint. So in TIG, similarly, instead of non-consumable electrode is used. This is 2 times gate question. In TIG, non-consumable electrode is used. Application is used for highly reactive materials. Used to weld highly reactive materials. In TIG, filler rod also we use, because we are not electrode is non-consumable, so there has to be some external supply of molten metal. So filler rod is used to fill the gap between the two metal pieces. Similarly, there is MIG, metal inert gas welding. The difference between TIG and MIG is, here consumable electrode is used. That's it, remaining everything is same. Consumable electrode is used. So earlier one is TIG, tungsten inert gas welding. So tungsten is electrode which is non-consumable. So here MIG is metal inert gas welding. The electrode material is same as the parent material. The plates which we are, suppose if you are joining aluminum plates, then the electrode has to be aluminum electrode. So parent, it has to, because it will form the joint, it will be the part of the joint, the electrode, consumable electrode. So that's why the material of the electrode is same as the parent material. Next one is submerged arc welding. Submerged arc welding is, here we use flux. Flux is used to join two plates along with electrode. Application is used to join plates of thickness up to 75 mm. So in arc welding, so electrode is the important element. So electrode, there are different types of electrode. Consumable electrode, it melts and supplies molten metal to the weld bead. So consumable electrode, it melts and supplies molten metal to the joint. As electrical conductor as well as the supplier of additional molten metal. It acts as electrical conductor because it will allow the electricity from it. Electrical conductor and supply of molten metal. In consumable, there are again two types. One is bare wire electrodes. That means bare wire means no coatings on electrode. Another one is coated electrodes. Next one is non-consumable electrode. So consumable electrode material is same as the parent material, that's why it's not mentioned. Non-consumable electrode. Non-consumable electrode is always bare wire electrode. There is no coating. Because it is not consuming means there is no need of coating. Always bare wire electrode. So examples are carbon electrode, graphite electrode, tungsten electrode. Carbon electrode, graphite electrode, tungsten electrode. So that's why in TIG, tungsten inert gas welding, the electrode is non-consumable. It is manufactured from tungsten, by tungsten. That's why it is called non-consumable electrode. That's about arc welding techniques. Coming into the physics of arc welding, how it works. Before going to that, another small topic is coating, electrode coatings. So here, depending upon the application we are using, we use different electrode coatings. So electrode coatings advantages: it deoxidizes melting material, helps to deoxidize weld means welding joint, removing the oxides from the weld bead, protects from atmosphere, and it absorbs entrapped gases. So these are the advantages. Types of coating. Suppose cellulose coating is used to produce shielding gases. Cellulose coating is used to produce shielding gases. Titanium oxide coating is used to produce slag. Which protects from atmosphere contamination. Ferrosilicon is used to deoxidize the weld. These are the major coating components in arc welding. Into the formulas in arc welding, heat generated, we are sending power supply of current I, heat generated equal to Q equal to I square RT. Heat dissipation HA delta T. Duty cycle, arc on time divided by total time, which is equal to arc on time divided by arc on time plus rest time. Total time means rest time is idle time. In a welding you may have to take rest time also, that you have to add. This is duty cycle. I square ds equal to I square dd. Duty cycle is means D is a duty cycle, is a current, and S is the current. It is whatever the current mentioned on nameplate of a particular equipment. Suppose if you look at the electrical generator, in generator they will give specifications, current, voltage, so that those are called rated values. And ID is desired current. Similarly, DS and DD are rated duty cycle, desired duty cycle. Next one is number of electrodes required for arc welding equal to total volume of weld bead divided by volume per electrode. Mathematical formula. So welding speed equal to length of the weld bead divided by weld time. Length of joint or weld bead divided by welding time. Nothing but distance by time. Velocity equal distance by time. Distance is nothing but here length of the joint. Number of passes. So if you want to join very thick, high thick plates, in one pass you can't complete the welding, fill the joint. So you need to go for multiple passes. So total number of electrodes divided by number of electrodes per pass. This is about formula here. Characteristics of arc welding. So in arc welding the problems will come based on this formula which we are now going to discuss. Here L is the length of electrode gap. Arc length or gap between tip of the electrode and workpiece. Gap between electrode and workpiece. IS is the short circuit current, the current passing through this. V0 is the open circuit voltage. Resistance equal to V0 by IS, short circuit resistance. So we assume that voltage is linear relation, length of the gap, the arc length is linearly related to the voltage at arc. So voltage E equal to A plus BL. A and B are constants. Another V equal to, if you simplify that, V naught minus V drop. So the drop voltage is also written as V equal to V naught minus V naught by Is into I. One formula and this one is one formula. These two equations are used to solve the problems of in arc welding. Equation 1 and 2 are used to solve arc welding problems. Next is non-fusion welding, which is where parent metal won't melt, is called non-fusion welding, and in that there is special welding techniques. Soldering, first one. So soldering is for joining electronic circuit boards, as we know that. So here the parent metal won't melt. The temperature is filler material for soldering is combination of lead and tin. Filler material is used for soldering. It is used when temperature of the joint is less than 27 degrees. Temperature of joint is less than 427 degrees. If it is more than 427, the tin which is as in filler material, it evaporates. So then the compound won't form, the joint won't form. Application: joining electronic components, circuit boards. Joining electronic components in circuit boards. Next one is brazing. When the temperature of the joint is greater than 427 degrees, then we need to use brazing. Filler material here is combination of copper and zinc. Copper and zinc. The advantage is here no joint preparation is required, and the molten metal flows due to capillary action. The filler material of molten metal flows due to capillary action. Braze welding. Filler material is copper plus tin. Here joint preparation is necessary. Because of joint preparation, the filler material flow is due to flow of filler material is due to gravity action. This is about braze welding. Braze welding is used to join light thickness components. Next one is pressure welding, which is also called as resistance welding, which is a form of non-fusion welding. Here there is no melting of filler material, so the joint is formed with the help of heat and pressure. So joint is formed due to heat and pressure. It is a form of non-fusion welding. It is again divided into three types majorly. One is spot welding. Here in spot welding, small projections are used. So at a particular spot, supply power through electrode, supply power, then joint will form. Apply heat and pressure. At a particular spot, the joint will form. This is spot welding. Next is seam welding. So instead of at a particular point continuously welding, seam welding is continuous welding. So in the same diagram, instead of electrodes, use rollers. Rollers are used. So it is seam welding. Joint is formed with the help of continuous rolling of the rollers on the two sheets by applying pressure and heat. Projection welding. Welding takes place only on projections. It's called projection welding. So in pressure welding, whatever the problem comes, heat generated. In pressure welding we supply power, heat generated equal to I square RT. I is current, R is resistance, T is time of current flow. That is power generated. Power required, heat required is equal to mass into latent heat and sensible heat or specific heat. Efficiency of the joint. Melting efficiency. Heat required by heat generated.